Hi, we're going to finish up with 4 theorems. The first one says congruent central angles have congruent arcs, which have congruent chords. So we know central angles have the vertex at the center. So whenever you have these angles, which are congruent, we know the chords are going to be congruent and the arcs are going to be congruent. And we'll practice that here in a little bit. Now, we use the second theorem a lot. It says that chords equidistant from the center are congruent. So they're going to have these little segments like AE and AF, and they're going to be marked as congruent. And that's going to indicate that these chords are both going to be the same length. Now, the third and fourth theorem, they are converses of each other. The third one says that whenever you have a radius or diameter, it's going to come down, and if it's perpendicular, it's going to bisect your chord and it's going to bisect your arc. We will use this a lot. Now, we also have the converse. If it's bisected first, then we know there has to be a right angle there. So let's practice these real fast. Now, we know that these chords are both the same distance away from the center because it's given that they're both 9. So that indicates to us that the chords are the same length. And since there's a right angle, we know these are bisected. So 12 and 12x is 24. Now, since the chords are the same, the arcs will also be the same. So y is 120 degrees. Since they tell us both of these chords are the same length, that tells us that they have to be the same distance from the center. So x has to be 3.2. I'm seeing that the chords are both equal distance from the center. So that means they are congruent. And it doesn't say so, but since it is bisected here, we know there has to be a right angle. Just thought I'd point that out. So each little piece is 5. So x is wanting just that 1/2. So that means it has to be 5. Now we're getting into the Pythagorean theorem. Now, you have to be careful because a lot of people just do it fast and use 20. But 20, as we know, is this entire chord. And since it's a right angle, we know it's actually bisected. So we need that little red side there of the triangle, which is 10. So we know how to do Pythagorean. 14 squared equals x squared plus 10 squared. So just be careful. 14 squared is 196 plus 100. Subtract it over and get 96. So the square root of 96, and let's round it to the nearest tenth, is 9.8. Now this one, I always refer to it as a clock because we already know that radii always have the same measurement when they're on the same circle. So we're going to rotate the radius and we're going to try to make a right triangle, which we have here. So I'm going to redraw in my radius, which has the value of x. Now, since there's a right angle here, we know that that chord's bisected. So it's 9.5, or 9 divided by 2 is 4.5. So it's Pythagorean again. So x squared is your hypotenuse equals 1.9 squared plus 4.5 squared. All right, so x squared is 23.86. Let's square root that and round it off to the nearest tenth. And I get 4.88, which rounds to 0.9. And then lastly, we know the chords are both the same distance from the center. And we see a right angle. So that means these chords are the same length, which means these arcs are also the same length. So x is 50. And that is it. Let me know if you guys have any questions.